Hey, I had a couple of questions on continuity and piecewise functions, so I was going to do a couple extra examples and post them. So this one's an example of number 5 off the homework, and this is the question I got. So when you guys get these, you don't get a graph, you just get this on the homework, and they're asked to find these things. So I'm going to go through kind of the table version, and then go, you don't really need to do all this, because then I'm going to kind of show why on a picture, why this makes sense, and you can kind of simplify things. But here's sort of the idea of continuity and what we're looking at. So for this first part, it's asking for, is the function continuous at x equals 1? Okay, so x equals 1 is part of this one, because it's for x is less than or equal to 2. And so for this one, I can just put 1 in there, and 1 minus 1 is 0. And so does that mean it's continuous or not? Well, if I come down here and I make a little table of what happens when I approach x equals 1, so if I come at it from the left, so if I'm at like 0.9, it's negative 0.1. At 1, it's 0, and at 1.1, so a little bit past 1 now, it's 0.1. So it seems like if we're thinking of this on a graph, oops, a terrible graph. So there's my 1, and at 1, it's 0, so at 0.9, it's just a little below, and at 0.1, it's a little above. So yeah, it seems like it's just going to go through 1. So as I approach from each side, it comes to the same thing, and there's no jumps, there's no gaps. So that would be continuous. And anytime we're looking like on the interval of a line, it is continuous. So if this had said, is it continuous at x equals 17? Or sorry, it couldn't be 17, negative 17. I would say yeah, because it's a line. And if you think of what a line looks like, it's continuous. So it's all good. And then the person who wrote me had said, the 4 kind of makes sense because no matter what, it's 4. Exactly. So that's this one. Down here at x equals 3, yeah, it's just going to stay 4, right? Because when it's, oops, I should have 3's here, sorry. As I'm approaching 3, shoot, no, I messed up my example. Okay, pretend I didn't do that. So here, as I'm approaching 3 from either the left or the right, it just sits there and it stays 4. Okay, so these are really 2's. So now we're here at x equals 2. And this is the one that's tricky, and this is where you have to kind of pay attention. So the ones that aren't on the boundary, they're going to be continuous. And I'll show you that with the graph coming up in the next question. The part where you have to pay attention is right here on the boundary. So at x equals 2, we got to figure out, as we come from the left and from the right, are we coming to the same value or at different values? So here, if I think of this one, and this one could actually equal 2, but so I just showed it at 1.9, we come out to 0.9, so a little less than 1, 1.99, a little less than 2, getting closer to 1, and at 2 it actually just equals 1. So when x is 2 in this one, the output, the y, would be at 1. But down here, this one it can't equal 2, but I can see at 2.1 it's 4, at 2.01 it's 4, at 2.0001 it's 4. The closer I get to 2, this thing's stubborn, right? It's going to stay at 4. So that's that. So this one, if x could be 2, the output, it seems like it's heading for 4, but this one it's heading for 1. So that's going to be not continuous because there's that step between them. And then over here, I threw a graph in the computer and had to draw it because it draws better than me. So here you can kind of see what I was saying. When x is 0.9, we're a little bit below. At a little bit below, and then at 1 we're at 0, at 1.1 we're a little above. So that's what I was saying. On a line, if this had been any point less than 2, it's continuous, and the same thing with this. So it's those boundaries that you got to watch out for. And there we are showing when x was 2 here, it was 1, and then when x was 2 here, it hops up to 4, but it can't actually equal it because of the not included. So the other question I had was number 7, same basic idea. This time I'll use the graph to kind of save myself a little algebra. So I threw these in a grapher, and you don't have to do this at all, but I just wanted to show you what they would look like. Anytime you have a polynomial, so like x squared, x cubed, x to the 4th, positive exponents without negatives in them, it's continuous. So looking at these two, I know that is continuous everywhere. The only spot I'm going to have problems is on the 1. And if we look at the graphs, this first one is sort of this upside down parabola here. This one is this parabola that's going oh, we're only seeing that much of it. There it is. It'd be going this way. I'm like, where's it going? So we're seeing that much of it. So this is just going to go up forever. But where the discontinuity is going to be is right here on the boundary. So you wouldn't have the graph, but looking at this, you can just go, okay, when x is 0, that goes with this one, and yeah, that's fine because it's a parabola and parabolas are continuous. So we say, yeah. Here at 1, we'll come back to that for a second. 2, yep, another parabola, so that one we'd say yes, it's continuous. And then for this, x equals 1, it's -4 here. If I put in 1 there, just to see where it's going to go, it'd be -1 minus 2, and that would make -3. And that's what we're seeing right here. If I put in a 1 here, I'd have 1 plus 3 would be 4 minus 2 should be 2. That's what we're seeing right there. So you see how these are coming out to different values when I plug in the 1? What that's demonstrating is that gap, and then that's a discontinuity. Cool. Hopefully that helps.